So I will be doing section 8.2, the surface area of revolution. My problem is y squared equals x plus 1 from 0 to 3 rotated about the x-axis. First, I'm just writing down the equation for the surface area of revolution. So the surface area equals the integral from a to b of 2 pi f of x times the square root of 1 plus f prime of x squared dx. And I'm just going to simplify my original equation so that I have y alone, and so y equals the square root of x plus 1. And then taking the derivative of that equation, y prime equals 1/2 x plus 1 to the negative 1/2. And then just rewriting the equation, surface area equals the integral from 0 to 3 of 2 pi times the square root of x plus 1. And then that is multiplied by the square root of 1 plus our derivative, which is 1/2 x plus 1 to the negative 1/2. And that whole derivative is going to be squared. So right now I'm just going to work within the square root to get some things simplified. So if I'm squaring that derivative, I'm just multiplying it by itself. So that's what I'm doing right here. And then that'll equal 1/4 times x plus 1. And then if I write it back into the square root, it'll be the square root of 1 plus 1/4 times x plus 1. And then I'm getting a common denominator. So my common denominator is going to be 4 times x plus 1. So then that 1 is going to turn into 4 times x plus 1 over 4 times x plus 1. And then I'm going to add it to 1/4 times x plus 1. And then that equals 4x plus 4 plus 1 over 4 times x plus 1, which equals 4x plus 5 over 4x plus 4, and then we put that back into the square root. And then if we just take the square root of the numerator and denominator separately, we have the square root of 4x plus 5 divided by the square root of 4x plus 4, and I just simplified that. So I took the square root of 4, and then I took the square root of x plus 1, which then will equal the square root of 4x plus 5 divided by 2 times the square root of x plus 1. And then I'm just going to put all of that back into the original equation. And then the square root of x plus 1 cancels in the numerator and then the denominator. And then I brought out my 2 pi over 2, and then I have the integral from 0 to 3 of the square root of 4x plus 5 dx. I'm just going to use u substitution, so my u is going to be 4x plus 5, and then my du is going to be 4. And so then I'm going to put that 4 out in front of the integral. And so my new integral is pi over 4 times the integral from x equals 0 to x equals 3 of the square root of u du. And if I take that integral, I have pi over 4 times 2/3 u to the 3 halves from x equals 0 to x equals 3. And then if I substitute my x terms back in for u, I've got pi over 4 times the quantity of 2/3 times the quantity of 4x plus 5 to the 3 halves from 0 to 3. And then at x equals 3, the answer is pi over 6 times 17 to the 3 halves. And then at x equals 0, the answer is pi over 6 times 5 to the 3 halves. And then subtracting those, you get the final answer of pi over 6 times 17 to the 3 halves minus pi over 6 times 5 to the 3 halves.